Okay, today we're going to look at verifying some more trigonometric identities. We're going to use our trigonometry facts, and then we're also going to use some facts that we've learned so far in algebra as well. So remember how your teacher is always saying that you have to remember what you did back in the course before? Well, this is a clear case of that. So let's take a look at the first problem that I have here. So let me get my pen. All right, so I have cosecant theta, cotangent theta, tangent theta equals 1. So remember, when we verify, we're only going to manipulate one side, because if we manipulate the other side, if we start multiplying and dividing, that means we're already assuming that these two things are in fact equal. But we don't know if they're equal or not yet. We have to verify that they're equal. So I'm going to start off, and I'm going to manipulate only my left side. So first of all, we know that cosecant is equal to 1 over sine. And I'm going to leave cosine as cosine. And then tangent, I'm going to leave that as well. So I know that cosine theta over sine theta times tangent theta, and I'm just bringing down that one. Sometimes you'll see that the one will be left off, but I'm going to bring it down. Now there are two different ways that I can do this, so both ways are absolutely correct. It's just basically you have to be able to show your work. So for the first way, I'm going to say cosine theta over sine theta. Well, we know that tangent is also equal to sine theta over cosine theta. And we know that when I multiply this through, my sines cancel out, my cotangents cancel out, and I'm left with just 1. So that one works out. Now, if I want to do this another way, I also know that cosine theta over sine theta is equal to cotangent theta. And I know cotangent is equal to 1 over tangent. And 1 over tangent times tangent is equal to 1. So 1 again equals 1. And so that is the second way of doing it. All right, let's go to the next one. All right, so it says show that cotangent theta over cosecant theta is equal to cosine theta. All right, so we know that cotangent, again, is equal to cosine theta over sine theta. And we know cosecant is equal to 1 over sine theta. Well, we know when we divide, we're going to keep the first term. So we'll say equals cosine theta. We'll keep the first, so we'll say cosine theta over sine theta. Multiply change the division to multiplication. So I have my little multiplication dot there. And then I have sine. We're going to flip or use the reciprocal. So sine theta over 1. So this is elementary. This is multiplying fractions, right? Or dividing fractions. So my signs cross out. And I get cosine theta is equal to cosine theta. So it is proved. All right. Now this one deals a little bit more with our algebra knowledge and the things that we remember from algebra. So first of all, I know that these are, well, I am going to use my trigonometry a little bit. We know that these are even and odd functions. And so sine is odd, so we know that when we multiply, when we have an odd, that the negative is going to become negative. So that's sine theta, but this whole thing is squared. Minus a negative for cosine. Cosine is even, so that's just going to give me cosine theta and everything squared. All over, remember, we have, it's odd, so it's going to be negative sine theta minus cosine theta because cosine is even. And I'm going to leave off the right hand side just for now, just because I don't want to run out of room on my whiteboard. Okay, so now we know that anything squared is positive. So we have sine squared theta minus cosine squared theta all over negative. Let's go ahead and pull out a negative 1 because everything is negative. So I'll do sine theta plus cosine theta, and that's our algebra right there. So we've already done some algebra. Now if you look at the top, you'll also notice that I have the difference of squares. And so when I have the difference of squares, I can rewrite it as, and this is algebra again, so we have sine theta minus cosine theta times sine theta plus cosine theta. All right, all over negative 1 times sine theta plus cosine theta. All right, so I have a sine theta plus cosine theta up top and at the bottom, so that can cross out. Remember everything that's in that parentheses, and again, this is a little algebra review. They're a team now because that plus sign is connecting them. So if I'm gonna, I can't just get rid of the sine theta and the sine theta, I have to get rid of the sine theta plus cosine theta because it's now connected. And so now I'm left with sine theta minus cosine theta all over negative 1. So I'm going to multiply everything by negative 1 because I don't want to have that negative 1 in my denominator. So it's going to give me negative sine theta, or divide by negative 1, however you want to think about it, equals cosine theta. Now it's supposed to equal cosine theta minus sine theta. Well, our algebra lets us know that this is equal to each other. So I'm just going to switch it around. So I have cosine, my cosine theta is positive, minus sine theta, and so it checks out. Okay, so now let's look at another one. We have sine squared theta minus 1 over tangent theta sine theta minus tangent theta equals sine theta plus 1 over tangent theta. Again, I'm going to use a lot of algebra to help me solve this. Not so much of the identities, but just what I know about algebra. So again, at the top, and I'm only going to look at the left-hand side again. Those have been the sides that have been the nastiest, I guess. So we have sine squared theta minus 1, which is also another difference of squares. So I can rewrite this as sine theta minus 1 and sine theta plus 1. And then at the bottom, or in my denominator, I can see that I can pull out a tangent. And look, guys, I'm guessing on what I should do. There's lots of different ways I can do this, but I want it to look like my right-hand side. So I know I need a tangent theta, and I know I need a sine theta plus 1. So I'm trying to pull that out in any way possible. So I'm going to pull out my tangent theta because I know I need that to be in my denominator. And I get sine theta minus 1. Well, I have a sine theta minus 1 up top, and I have a sine theta minus 1 in my denominator. So I get sine theta plus 1 over tangent theta, and it checks out. And I think that's it for me today, and I hope that this helps.